Hello and welcome to today's CamLogic Tech Tuesday. Today we're going to be talking about NX11 sheet metal enhancements that came out with the release of NX11. Now NX11's been out for a little bit, but this is more of a, in case you missed it, sort of Tech Tuesday. My name is William Hall. I'm one of the AE team leads here at CamLogic, and I have over 6 years of support and technical support for both pre-sales and post-sales for Siemens related products. Today, we're going to be looking at the NX11 sheet metal enhancements to commands like dimple, bead, advanced flange, and joggle, bridge blend, and lightning cutout. Now, some of these have had changes, and some of them are new to NX11 altogether. We're going to be designing a sheet metal enclosure to hold a part using these new commands and showcasing them in this demonstration. So, with that, let's jump over into NX and take a look at what we're going to be doing. So what we have here is we have an assembly that includes both our future sheet metal component that's going to make our enclosure and the part that we need to enclose. So let's jump right in to our sheet metal part. I've gone ahead and done a little bit of prep work for this in creating the bottom half of the enclosure. One thing I did not account for, though, is that it is offset from the part a little bit. Using a datum plane, I have constrained the location of this 50 offset from the coordinate system, but I really want it to be about 40. So I'll bring that up by adjusting my datum plane offset. Alright, when doing so, you'll see here I have a small protrusion at the bottom of my part that I have to account for in my sheet metal design. I'm going to use the dimple command to be able to create an offset dimple to make room for this feature. Now I've also gone ahead and created a few sketches to help in showcasing some of these commands. Save time in this demonstration for instead of sketching and drawing all this up, but instead be able to showcase this off quickly and easily. So here, selecting a predetermined sketch I've created, I have room now for this protrusion except for these two cross beams here. For this, you see we can adjust the depth and whether or not we're referencing from the inside or outside of the material. So I'll create my dimple. Next we're going to make a bead to account for these crosses. Now, when selecting a bead, we have now improved capability within the bead command to either go below the same height of the material or above it, creating features like these. For this part, we're going to keep them at just 3 millimeters and flush with the dimple protrusion that we've already created. Alright, now that we've made room for this protrusion, we're going to come over to the top side of this part and design a tab to go on top. So, again, I've gone ahead and created a sketch for this to create this tab. And so what we want to do from here is be able to create a flange coming down the side of this curved edge. For this I'm going to use the advanced flange. I'm going to grab that top edge, reverse its direction, and you see here we can have adjustments based off of length, coming off, or off of angle. You'll see it adjusts the size of the edge blend. Now for this, I'm going to keep it just at 90 degrees. You'll see we can have our length reference, whether it be from the inside or outside of the virtual intersection to the tab faces, or based off of web or to the DIN 6935 standard. We also have the capability of compensating for a flat pattern both at the start and end of the flange. Opening or turning this on will allow us to adjust by a certain degree. I'm going to create my advanced flange here. I'm going to showcase another type of advanced flange, an advanced flange to reference. For this, you'll see here at the bottom, our sheet metal part extends out and references this extrusion here, this reference face. We'd like to do the same to the top. So I'm going to grab this edge here and choose to reference this face right like this. Now you see it comes out and makes our bend straight, and it goes on past our face. We can come in and choose to infer length in our flange properties to instead adjust the edge of this flange to match the face that it's referencing, like this. Now that I've created my two flanges, I notice that on my side here I have a small offset on this face of this part that we're working with, and I want to accommodate for that. How can I do that? Well, I can use the joggle command, select the face that I'm looking to create the offset from, and then specify a location where I'd like to create that. Here you'll see we have an offset set of this plane, and we can adjust its location based on that plane by adjusting the runout or the length of the offset, or making clearance by adjusting the location of it. Now I also notice I have a second offset that I have to account for. So I'll go back and open my joggle and adjust the limit type instead of from a single to a twin. Here it'll ask for a second plane, and you'll see here it accommodates by joggling inwards and then back outwards. The next thing we want to do is we want to attach the bottom part of our sheet metal design to the top. We can do this quickly and easily with the bridge blend command. Here it'll have us select a start and end edge, and then give us options as to how they are connected. Whether we fully extend the top or start edge, extend the bottom or end edge, or extend both edges where they meet in the middle. For this design, this is what we're looking to do here. Next, in our part we need to make a couple cutouts for our design. For this I'm going to use the lightning cutout command. We have both the option of making a whole lightning cutout and a user-defined one. Again, I've gone ahead and created a sketch for this. And here we can control the length of the cutout, as well as the angle of the cutout. Once I've chosen my parameters, I'll go ahead and apply this, but I have one other cutout I need to make. This time a whole cutout. Here it's basing it off of a point. And again, we can come in and put manual parameters in, or we can reference predetermined standard ones. So standard diameter of 55, a little too big, however 35 will meet our needs. With the parameters selected, I'll go ahead and finish the command. Now that we've made room for our cutouts, the last thing I want to do is showcase one more thing about the bead command that was enhanced. So I'll go back into our bead. And what I want to show is we now have the capability of creating beads that go over not only flat surfaces, but rounded edges as well, and following along the edge onto the sheet metal part. We can come in and make adjustments for both the depth and the radius for these beads in our design. Once we're satisfied, we'll go ahead and click OK. So let's go ahead and take a look at the flat pattern for this component. We'll generate a flat pattern, selecting our top face. And we'll make that flat pattern active as our view once it's generated. Excellent. So let's navigate to this component, and we'll set our view to the top and set our view to our flat pattern. As you can see, in our flat pattern, it accommodates for the bend information and angle for our beads that we placed either straight or angular over the edges. It accommodates for our lightning cutouts and all the information in regards to those, as well as our advanced flange and joggles that we created. So all of the information for all the tools that we went over today transfers over to your flat pattern. With that, that will conclude the demonstration. If there are any questions or you'd like more information about the complex sheet metal functionality we covered today, please reach out to me at williamh@camlogic.com. I'd be happy to answer any questions or provide you with more information on what we covered. If you have any other questions or any need of support, don't hesitate to give us a call at 855-955-0900 or reach out to us at email us at support@camlogic.com. We're available 8 a.m. to 5 p.m. Monday through Friday, and we'd be happy to help you. Thank you very much. Appreciate you tuning in. Please stop in again for our next Tech Tuesday. We'll look forward to seeing you then. Thank you. Have a good day.